NASA's most powerful camera on Mars just photographed something that looks engineered. Perfectly geometric honeycomb structures stretching across the Martian surface for hundreds of kilometers. And nobody can fully agree on what created them. These are not small formations. Some of these individual hexagonal cells are over 10 kilometers wide. They tile across the landscape in repeating geometric patterns, so regular, so precise, that when the first images were released, thousands of people online immediately asked the same question: who built these? Nobody built them. But the real answer might be even more extraordinary. The images come from HiRISE, the high-resolution imaging science experiment, mounted on NASA's Mars Reconnaissance Orbiter, which has been circling Mars since 2006. HiRISE can resolve objects as small as 1 meter across from orbit, making it the most detailed camera ever sent to another planet. The honeycomb structures it captured are located primarily in Hellas Planitia, the largest confirmed impact basin on Mars, roughly 2,300 kilometers wide and 7 kilometers deep. It is the deepest point on the entire Martian surface. In 2024, a team of researchers published detailed analysis of these polygonal patterns in the Journal of Geophysical Research, Planets. Their findings pointed to a process that directly implies Mars once had something we desperately want to confirm: large amounts of subsurface water ice and possibly liquid water interacting with the soil. Here is the leading scientific explanation. On Earth, nearly identical polygonal terrain exists in Arctic and Antarctic permafrost regions. In places like Svalbard, northern Canada, and Siberia, repeated freeze-thaw cycles in ice-rich soil cause the ground to contract and expand seasonally. Over thousands of years, this process creates networks of geometric cracks that organize into remarkably regular polygonal cells, pentagons, hexagons, and other shapes, that can stretch across vast areas. The physics that drives this is well understood on Earth. The Martian honeycomb structures share the same geometric characteristics. The leading interpretation is that these formed through analogous freeze-thaw or thermal contraction processes acting on ice-rich Martian regolith, possibly over millions of years during periods when Mars's axial tilt was different from today, exposing these regions to different thermal conditions. Mars's obliquity, the tilt of its axis, varies dramatically over long timescales, cycling between roughly 15 and 45 degrees over millions of years, compared to Earth's relatively stable 23.5 degrees. During high obliquity periods, ice distribution on Mars shifts significantly, and regions like Hellas Planitia could have experienced conditions conducive to these freeze-thaw processes. But there is a competing hypothesis that makes the story more complex. Some planetary scientists have proposed that the structures could be related to convection, slow churning motion in the subsurface material driven by heat from below. This process, similar to what creates Rayleigh-Benard convection cells in heated fluids, could theoretically produce hexagonal surface patterns. If this is the mechanism, it implies ongoing or geologically recent heat flow beneath the Martian surface, a finding that would have major implications for the question of whether Mars is truly geologically dead. A third hypothesis involves salt tectonics, the slow movement of buried salt deposits that rise and deform the surface above them, similar to salt domes on Earth. Hellas Planitia's low elevation means it has the highest atmospheric pressure on Mars, and conditions there could have allowed mineral-rich brines to exist closer to the surface. What all three hypotheses share is a requirement for water, either as ice, as liquid brine, or as a component of the geological processes involved. The honeycomb structures are not proof of liquid water on Mars today, but they are physical surface evidence of water-related processes that shape the Martian landscape, potentially more recently than previously assumed. And the scale matters. These are not isolated formations. HiRISE has documented honeycomb polygonal terrain covering thousands of square kilometers across Hellas and other low-lying regions. Whatever process created them operated on a massive, sustained, planet-wide scale. Follow for more on what Mars is still revealing. And tell me, when you look at these perfectly geometric patterns on another planet, do you see geology, or do you see something that still needs a better explanation?